Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 1, Introduction to Statistics. Is for some reasons you didn't watch the first two videos, I strongly advise you to click on section 1.1, Statistical and Critical Thinking, and section 1.2, Type of Data, to find out about different concepts we already covered, like the definition of statistics, different type of data, quantitative and qualitative data, different types of quantitative data like discrete data and continuous data. We talk about population, sample, plenty of concepts that's already covered. But in these sections, we would emphasize more on collection of sample data. So, in as key concepts, when we're analyzing sample data, it is essential to use an appropriate methods for collecting those sample data. This section includes comments about various methods and sampling procedures. Of particular importance is the method of using a simple random sample. So we said method of using simple random sample, right? So we will make frequent use of this sampling method throughout the, many examples we're gonna do. Uh, all right. So as you read through this, that I would advise you to check either the hard copy of your book or the ebook. Remember this. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical tutoring can salvage them. So very important to make sure that you use the appropriate way to collect your data. Um, Basics of designs of experimenting and collecting data. So we need to talk first of all about the gold standard. Gold standard randomness with placebo treatment group is sometimes called the gold standard because it is so effective. So when you conduct a study, you have two different two of them, so because statistical study has two of them. We can, when you design statistical study, we can either proceed with research. We typically obtain data from two distinct sources, either from observation or observational studies. So that means you just sit and observe, or you can only distribute, a questionnaire, or you call over the phone. We call this observational studies because you don't impose any treatment. But the other way the other source you can obtain your data from is experiments, right? So for the experiments, you impose treatment. A treatment is applied to part of a population that we call a treatment group and reserves ourselves, So many studies in this case are conducted using experiments. If we want to verify the effectiveness of a new medication for headaches, or anything that has to do with treatments, we call it experiments. But if there is no treatment that will be imposed, is observational. So as a definition here, we said experiment applies some treatments, we apply some treatments, and then proceed to observe its effectiveness on the individuals. So the individuals in experiments, we call them experimental units, but if it's about people, we call them subjects. So we have two groups, usually in an experiment, a treatment is applied to part of a population. We call it a treatment good, and response are observed. Another part of the population may be used as a control group. So we're going to have a chance to talk about it. The control group in which no treatment is applied. right? The subject in both groups are called units, as we said. So the group that doesn't receive any treatment, we call them control group. Usually we give them something that we call placebo. So that's what we defined in the previous slides. So we said the placebo is a harmless and ineffective pill medicine or procedure sometimes used for physical, psychological benefit, or sometimes used by researchers for comparison to other treatments. So a placebo such as sugar pill has no medical effects, So when you conduct a study where you need to impose treatment, either give medication or study the brain, it's on research on cancer and anything, you have two groups, a group that receive treatment, a group that doesn't receive treatment. If you conduct a study about the effect of alcohol, so a group drank, another group doesn't drink. So it's not really observation because those are treatment because people would inject or would drink something or they would smoke something. It all depends on for which reason you conduct that study. If you conduct a study about smoke habit, you would have two groups. A group that would smoke nonstop, that we call it a treatment group, and you would have a control group that wouldn't smoke anything. We call it control group. Or sometimes we would give them a placebo, as we said, which is a harmless fake treatment that is made to look like a real treatment. So that's very important to see that. So we said observational study. For the observational study, what we do with a researcher observes and measures characteristic of interest or part of the population. So observe and measure specific characteristic without attempting to modify the individuals being studied. So it's just sit and observe. Researchers want to measure the amount of time people spend doing various activities such as paid work, childcare, socialization, so you can just sit and observe. How many people would walk into a coffee place to order a hot latte or a cold latte? So those are just observation, but at the end, we would conclude with decisions when based on the parameters previously established. All right, so you understand we have two ways to as we said, we have two sources to collect data. We said we can collect our data either from experiments or from observational. As an examples, we're gonna just go very quick over these two exercises. The first one, the first one says, determine whether the study is an experiment or an observational study, and then identify a major problem with the study. So we can do it that way. All right. The first one, in a survey conducted by USA Today, 1,465 internet users choose to respond to this question posted on the USA Today electronic edition. Is news online as satisfying as print and TV news? 52% of the respondents says yes. Do you feel like it's observational study or experiment? Is there any treatment imposed here? No, because you don't have any treatment. They don't impose any treatment. In this case, we would say it's observational. So we would conclude with this one, observational study. Okay, so we're gonna consider this one as an observational study because the sample is convenient sample consisting of subjects who decided themselves to respond. That's really voluntary. Such voluntary response samples have a high chance of not being representative of the larger population. So the sample may well be biased also. The question was posted in an electronic edition of a newspaper. So the sample is biased from the beginning. It's not like we have a very representative sample. So that's really voluntary based and it's observational. There is no treatment imposed. Now, for B, exercise B, we said the physicians have study involved 22,071 male physicians. Based on random selections, 11,034 of them were treated with aspirin, and the other 11,034 were given placebos. The study was stopped early because it became clear that aspirin reduced the risk of myocardial infarctions by a substantial amount. So do you feel this is observational study or experiment? Yes, it is experiment. This one is experiment. There is a treatment that is imposed. So treatment is imposed. The sample subjects consist of male physicians only. So that's the reason. Remember, they said, oh, you know what? Identify a major problem with the study. A major problem of this study, like they go only with male physicians only, right? It would have been better to include females. Also, it would be better to include males and females who are not physicians. But most importantly, this one is experiment. Second problems are still the same, even though I put number two. We can go over it. A researcher for a consortium of insurance companies plans to test for the effects of drinking on driving ability by randomly selecting 1,000 drivers and then randomly assign them to two groups. One group of 500 will drive in New York City after no alcohol consumption, and the other second group will drive in New York after consuming 3 shots of Jim Beam bourbon whiskey. So, which is really bad. You should never suggest that someone would take the wheel drive after being drinking. But even though that, we're not making any judgment because treatment is imposed because they need to drink something, and you have two groups: a group that receive placebo and a group that receive that drank real alcohol. So it's experiment. Remember, experiment treatment is imposed. Treatment doesn't mean only drinking or take medication. If they study the, your brain with some electronic device connect to your brain is also experiments, right? So now identify a major problem with this study. You could already see it. This experiment would create an extremely dangerous and illegal situation that has a real potential to result in injury or death. Remember, you tell people to drink and then drive after. It's difficult enough to drive in New York City while being completely sober. Don't tell me if you are not sober, what would happen, right? So that's a big problem with it. We can go with the next problem. The Children's Defense Fund report that among secondary school students suspended in one region, 67% were suspended at least 3 times. That statistic was based on 3 students. Well, you see, 67, but only 3 students. That's funny. But remember here, do you feel like there is any treatment imposed? Yeah, no, 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 no treatment imposed. This one is observational study then. Observational. Now, what's the problem? I mean, what is the major problem with this study? Yeah, the sample size. The sample size is only 3 students. It's very too small. So we don't have enough people participating in that study. So the sample size is too small, right? There are only 3 people participating in this study. So it's not good. Now, you understand at some point that the definitions when you conduct a study, this study the source it could be either observational or experiment, but designing a statistical study, first of all, you need to identify the variable of interest, develop a detailed plan for collecting data, right? Collecting the data, describe the data, using descriptive statistics. That's something else we need to talk about. It's about descriptive statistics that we would have a chance to address very quick. Now, you understand the observational and studies and experiments. Good design, that's what we're going to talk about. We're going to talk about the design of a statistical study. So, good design of statistical study starts, as we said, by identifying the variable of interest, your focus, and the population of study, right? So, it's but for example, if you want to do a good design of experiments, remember you have a treatment group and a control group, right? So or two groups, in this case, doing replication or blinding or randomness is very important, right? Because when you do experiments, if you try to, if you're teaching someone to fly an airplane, you're not going to let someone fly a plane from New York to Paris, for example, on day one. You should create an environment that looks like reality, but in fact, it is only simulation. So there we have different design that we can use or different design we can use for experiments. Replication is one of them. Replication is the repetition of an experiment on more than one individual, right? So good use of replication requires sample size that are larger enough so that we can see effects of treatments, right? So that's very important to see. We have blinding. Remember we said replication is the repetition of an experiment on more than one individual. Blinding, blinding is a technique used when the subject doesn't know whether he or she is receiving treatment or is a placebo. You conduct a study, the researcher, you have double blinding, of course, we're going to talk about, but you know, the researcher knows who received the placebo and who does not receive the placebo. It's like when you give, let's say you give some medication to two groups. One person receive a placebo, that means the fake medication, and one person receive the real medication. But except we don't tell them which group received the fake or the real medication because at some point they can have the same side effects. Even in the group who receive placebo doesn't receive the real medication, the fake medication, but can have the same effects, right? So, we said blinding is a way to get, blinding is a technique in which whether he or she she doesn't know whether the subject doesn't know whether she or he receiving a treatment or placebo. So blinding is a way to get around the placebo effects, right? Which occurs when an untreated group reports an improvement in symptoms, right? So we want to make sure they checked about it. Double blind is that both the researcher and the subject, none of them knows. All right. So, which means that blinding occurs in two levels, you know. So the subject doesn't know whether he or she is receiving the placebo or a treatment, but the experimenter as well, the researcher, doesn't know whether he or she is administering the treatment or the placebo. Of course, there is always uh, um, someone in a higher position would know which group, but the experimenter or the person who are in contact with this subject directly doesn't know which group received the real treatment and which group received the fake treatment. So we call that double blind. Randomization, remember we said, oh, you need to do good design of experiment includes replication, blinding, and randomizations. So randomness. So Randomness is used when individuals are assigned to different groups through a process of random selections, you know, really random selection. So the logic behind randomness is to use chance as a way to create two groups that are similar. We're not looking on people's face to say, oh, you would be in treatment group and you would be on placebo, on a control group. So we should do it in a way that they can all enjoy it without knowing that they place in a treatment group because of their appearance or their background or something. Okay, so that's very important. Now, um, sampling random samples, of n subject is select in a way that every possible sample of the same size and has the same chance of being chosen. Well, the same chance of being chosen. So a simple random sample is often called a random sample, but strictly speaking, a random sample has a weaker requirement that all members of the population have the same chance of being selected, right? So very important that we can look through it. All right. Anyway, we'll use various statistical procedures, and we often have a requirement that we have collect a simple random sample as defined, very important. Um, those are just the definitions. If we talked about the systematic sampling, we have a lot of definitions here to see, because all the sampling that's in addition to simple random sample because we have so many of them. But one of them is systematic sampling. We select some you know starting point and then select every n elements in the population, for example, or k elements in the population. So we know where we start, all right? So we call that systematic. So systematic is very important. Hopefully, you can review and understand these techniques, right? Because we have so many. Systematic sample is a sample in which each member of the population is assigned a number. So the members of the population are ordered in some way, in like a starting number is randomly selected. And then we would say sample uh, sample members are selected at irregular intervals from the starting points, So that's what we are. An advantage of uh, you know, systematic sampling is that it is easy to use, right? In the case of any regularly occurring pattern in the data, it's very important. As you can see for the vehicles, right? Systematic sampling. Um, that's the first one. uh, you know, simple random samples, we can do it. So I would advise that you look at the, this sections, or you read these sections from the book. Convenience sampling. With convenience sampling, we simply use data that are very easy to get. No, just use whatever. I mean, use data that are very easy to get, like questions questions that people can answer by yes or no. That's something. Stratified sampling, we subdivide the population into at least two different subgroups or strata so that subjects with the same subgroup share the same characteristic, so that genders, right? Then we draw a sample from each subgroup. I know that would be the stratify. You see, we have two groups usually, as we said here. I'm hoping you can review it. So it's very important for the sample to have members from each segment of the population. So you should use a stratified sample for that. Depending on the focus of the study, members of the population are divided into two or more subsets, called strata. Okay. You see that here, that's stratified sampling. Next, okay. Remember, as we said, those are all different other techniques to, sampling techniques to collect data because we have so many different, beside doing simple random sample, but you have those too. So cluster sample, with cluster sampling, we first divide the population area into sections. Okay. Then we randomly select some of those clusters and choose all the members from those select clusters. Okay. So that we call it clusters. Clusters is really like partition the population in cluster, I mean group, then randomly select some clusters, then select all members from the selected cluster. You know. So we'll see, like you can see with these tweets as an example. Other definitions is multi-stage. For the multi-stage, professional pollster, and government researchers often collect data by using some combinations of the preceding sampling methods, But in a multi-stage sampling design, pollsters select a sample in different stages. And each stage might use different methods of sampling. That's what we're gonna do in some examples. But as you see, we talked about what the governments usually do in this area. Um, some examples before we even talk about simulation, because we have so many other ones we don't talked about yet. Census was one of them that's already addressed, but simulation, I told you about drinking habit. If we want to see the effect of drinking on alcohol on driving, so you're not gonna ask people to drive 2 or 3 bottles of whiskey and then drive. So that's something that can be done in a lab, where they would create the simulation, the environment that make people feel like they're driving in real life. But in this case, this would be all simulations. Now, let's do a few examples identifying which of these types of sampling is used. Is it random, systematic, convenience, stratify, or cluster? Um, so about that. So we said I believe exercise 3 and 4 are the same because just do it for enough space. We said that cormorant bird population densities were studied by using the line to insect methods, which affect observers flying along the shoreline of Lake Huron and collecting sample data at intervals of every 20 kilometers. So we collect data every 20 kilometers. So if you review all the different definitions I recently covered in terms of you know all three, whether we do systematic or random or convenience, stratify or cluster, which one would you use? Um, in this case, because as you can see, these data are collected and sampling at interval of every 20 minutes. The way we do it, I believe, in this case, systematics works better because you see, you could select some starting point and then select every key element. So that's exactly what they do in this example. So they're gonna select one every 20 kilometers. So we can say for these examples right here is systematic. So that's a sampling, that's the type of sampling we're going to use for this data. The the sexuality of women was discussed in Cher Hyde's book Women and Love, A Cultural Revolution. Her conclusions were based on sample data that consists of 4,500 mailed responses from 100,000 questionnaires that were sent to women. Right. I know that could be very confusing, but look, that's very easy to use, right? So I believe if this one is that easy, because it's just said, oh, you know what? Her conclusions were based on sample that consists of 45 male response. So, I believe that would be convenience. Use data that are very easy to get. So that's very easy to get. We're gonna consider this is convenient. In a Kelton research poll, 1,100 14 Americans, 18 years old of age or older, were called after the telephone numbers were randomly generated by a computer. And 36% of the response said that they believe in existence of UFOs. 1,114 Americans 18 years old or older are called after the. Oh, that's random. You see, you do some random. All right? You choose those randomly. So it's mostly simple random samples. So random sample, right? So that make it easier. But of course, exercise 4 is still the same type of questions. We need to identify if it's random, systematic, convenience, stratify, or cluster. We said a Harris interactive study involved 1,013 adults who were interviewed about washing their hands in restroom, and another 6,336 adults were observed in public restrooms. So you do this one at two levels, right? For this one, been doing at two levels. Um, let's say, I believe that at this point it would be stratify sampling because subdivides the population into at least two different subgroups so that the subjects with the same subgroup share the same characteristic and draw a sample from each group. So at this point, I would say these examples here because we have two groups, and we observe, so it would be stratify. The author uh, collect data by randomly select. Oh, you hear that? We said random again, but random can be something different as well. The author collect data by randomly selecting 35 pages from the previous edition of this book and then counting the number of words on each of these pages. That's not easy, right? But even though you have to count all of them, let's see what's other. Oh, cluster. Divide the population area into sections, then randomly select some of these clusters and choose all the members. So that's really cluster for that one. We would take sampling methods would be cluster. Well, what we're gonna do is advise you to to review and do more examples in this case so you can master it better. All right. But it's essential after you identify all types sampling methods beyond the basics or design of experiment and collecting sample data. Remember, observational study, observe and measures, but do not modify. You really need to pay attention to observations, right? So observation, observe and measures. Do not modify. So let's say when are the observations made? You can either review data collected in the past, past period of times, or one point in a time, or we can forward in the time, so there are two different levels that we can do it, types of data studies. Okay. Um, Cross-section study data are observed, measured, and collect at one point in time, not over a period of time. We go and sit at a coffee place and observe people ordering their latte. So how many people would order a hot latte between 10 a.m. or 8 a.m. to 10 p.m.? Or how many would order cold latte? So we can focus on one element, not two or three of them. So we can focus on one. Retrospective or case control study. All right, so that's past period of time. Data are collected from a past time period by going back in time through examination of records, interviews, and so on. So we can do that. It's like elections. You can call people and ask them how many who would they would vote in the next elections, or you can review past elections to make decisions about, behavior of voters. All right. Perspective is forward in time, a longitudinal or cohort study. Data are collected in the future from groups sharing common factors, such as smokers and non-smokers, right? So we can do that. Um, other as I said, we have so many different, you know, there are several ways you can collect your data, right? So the focus of the study dictates the best way to collect your data. As we said, you see, confounding is one of them also, right? So to produce meaningful, unbiased results, experiments should be carefully designed and executed. Okay. So, because experimental results can be wound by a variety of factors, being able to control these influence factors is important. So, one such factor is really confounding variables. So, confounding occurs when we see some effect, but we can't identify the specific factor that caused it, right? Uh, we have so many examples like this that we can eventually use. Let's say you want to open a coffee shop, it doesn't work, then you call someone to conduct a study and see how you can increase customers, at your coffee shop. But during the times you close to run that study, to hire an industrial engineer to run that study, a mall place is open nearby in the same week. So after you do your great opening, we cannot verify for real if now the increase of your customers is due to your new research conducted or innovation conducted by your industrial engineer, or because there is a new mall nearby, right? So we don't know yet. So confounding is very important because when an experimenter cannot tell the difference between the effects of different factors on the variables, right? So that's confounding. Control completely randomized experiment design. When you do completely randomly, in a complete randomized design, subjects are assigned to different treatment groups through random selections, right? So random selections. Randomized block design, because we have so many of them. In some experiments, it may be necessary for the experiment to use blocks, which are groups of subjects with similar characteristics. So one of them is random block design. So to use a random block design, the experimenter divides these subjects with similar characteristics into blocks. Then, with each block, randomly assign subjects to treatment groups, right? So I'm hoping that's what you would do in your study when we have a project to complete. Match pairs, you have so many of these. Remember, we said, those are all factors we need to review for experimental results to prevent the experimental results not to be wound. Match pairs design compare two treatment groups, such as treatment and placebo, by using subject match in pairs that are somehow related or have similar characteristics. So match pair design is also one of these we're going to use. That's another type design in which subjects are paired up according to similarity. So one subject in each group is randomly selected to receive one treatment, while the other subject receive a different treatment, right? So, um, you know, let's see for rigorous control group. For control group, as we said, we have so many of them, but for control group, carefully assign subjects to different treatment groups so that those given each treatment are similar in a ways that are important to the experiment. This can be extremely difficult to implement, and often we can never be sure that we have accounted all of the relevant factors. That's rigorous control group. Okay. Um, if you're here with me, you clap your hands and we can continue because control groups is also very important to review. All right. Um, Next is sampling errors. No matter how well you plan and execute the sample collection process, there is likely to be some error in the result. So you really need to verify and make sure that there is a margin, I mean, knowing there would be a margin of error at some point. Because in statistical, you could use a good sampling method and do everything correctly, yet it is possible to get wrong results, right? Um, so, you know, it's very likely at this point to see. So the different types of sampling errors, what are those errors? You can see um, sampling error or random sampling error because when the sampling sample has been selected with a random method, but there is a discrepancy between the sample result and the true population result. Such an error results from chance sample fluctuations, right? So a non-sampling error is the result, um, you know, is the result of human error, including such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstance. So non-sampling has nothing to do with the data you collect, but mostly because of computer, all this technology we use or the methods we apply, right? So non-sampling error. But we also have non-random sampling error. Is the result of using a sampling method that is not random, such as using a convenience sample or a voluntary response basis. Very important to see that. So experimental designs really requires much more thought and care when we can describe it in the relatively brief actions, right? Some people, in some places they even offer a full complete course in the design of experiments, So if you're interested to it, feel free, to do that. We're gonna go over two or three examples to finish, to conclude. In this exercise, we were asked to identify whether the observational study used a cross-sectional retrospective or prospective because remember we said we defined it before observational study observe and measure but not modify. We can do it past period of time, one point in time or forward in times, or if you want to call it retrospective is past period, cross sectional study is really data at one point, And prospective is like you do it forward in times, in the future. Now, we defined those already. My expectation is like we're gonna review these two exercise, those questions where they ask you to identify the cross. All right. Now, let's do it. A. Phase two of nurses health study was started in 1989 with 116,000 female registered nurses. The study is ongoing. So because this one is really observational, but what would you say? Is it retrospective, that mean past, or is it cross-sectional, like mean at one point, or is it prospective future? Yes, because the study is ongoing, so it's prospective. Prospective study, right? Prospective study. Remember, we said in a prospective study, data are collected in the future from groups that are share common factors, right? So that's let's see for the second one. Samples of the study of the subjects with and without heart disease were selected. And then researchers looked back in time to determine whether they took aspirin on a regular basis. Researchers look back, right? What's look back would be? Yes, retrospective. Thank you. Retrospective. Researchers from the National Institute of Health want to determine the current rates of marijuana consumption among adults living in states that have legalized the use of marijuana. They conduct a study of 500 adults in those states. Yes, that looks like more like, is it prospective, retrospective, or cross-sectional? Remember, we said cross-sectional data are observed, measured, and collect at one point, not over a period of time. So, right? Yeah, they conduct a survey of 500 in those states. So that's at one point. We're gonna consider this one as cross-sectional. Right? Okay, it is what it is. And the last examples we identify here, they're gonna ask us to identify whether the observational study, no, not this one. It's the same exercise, right? Now, let's identify which of these design is most appropriate for the given experiment. So we just did it for observational study, but now for the experiment, completely randomized design, randomized block design, or match pair design. So let's go as we go over the definitions. We can also see the exercise. Lunesta is a drug uh, designed to treat insomnia. In a clinical trial of Lunesta, amounts of sleep each night are measured before and after subjects have been treated with the drug. All right? So is it match? Is it randomized design, randomized block design, or match pair design? Let's see the definitions. Uh, randomized design, we said assign subjects to different groups through a process of random selections. But random block is a group of subjects that are similar but block different ways that might affect the outcomes. But match pair design compare two treatment groups. Then in a clinic, yeah, two treatment groups. It's like it because they study Such as treatment and placebo by using subject match in pairs that are somehow related or have similar characteristics before and after. If you have before and after, that's match pair design. You can use that. Might consist of measurements from subject before and after some treatments. So this is match. So match pair design. A clinical Lipitor treatments is being planned to determine whether it's effective, its effects on diastolic blood pressure are different for men and women, right? So which one this one can be? That's block. It's a randomized block design. So randomized, we said is randomized block. So remember what we said about the block randomized block design, right? Um, do we see it here? No, not here. Okay, I think yeah, randomized block design. A block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. So form blocks of subjects with similar characteristics, randomly assign treatment to subject with each block. So that's exactly what happened here. In this one being planned to determine whether its effect of diastolic blood pressure are different for men and women. Sorry, it's for men and women. So if it's for me and men and women. Okay. Lastly, you could even guess it. We said currently there is no approved vaccine for the prevention of infection by West Nile virus. A clinical trial of a possible vaccine is being planned to include subjects treated with the vaccine while other subjects are given a placebo. So for this one also, it's completely randomized design. Completely. uh, Randomized design. And that's what we're gonna say for the last one. Remember, completely randomized design assigns subjects to different groups through a process of random selections, right? So that's what we're gonna do. That's it. All right, in this chapter, remember this chapter one is only an introductions. We talked a lot about a lot of definitions, but don't feel like, oh my God, I need to give up because there are so many definitions. But moving forward, we would construct more graphs, construct tables, and solve some exercises using formulas, so or based on theorem, etc. But for now, it was very important to introduce the two big branches of statistics because so far that's one thing we didn't say. If you want to go over everything we do so far, we can be happy that we cover all of this, right? What we said exactly in this case, we talk about statistics with S without S, population sample. We talk about data that are variables, can be qualitative data, quantitative data. Quantitative data can be discrete or continuous. We talk about the level of measurements. We talk about parameter, all right? But one other thing I may probably didn't tell you about is, let me put one more slide. You know what? I can find a slide. I'm gonna just remove everything on this slide. All right. So if I put these slides here, one of the things I probably didn't talk about in this chapter that I was supposed to is, we said statistics with S is the science of collecting, organizing, summarizing, and, organizing data. But what I didn't tell you is that statistics has two big branches. One branch, we're gonna call it descriptive statistics, and the other branch we're going to talk about inferential. Are we gonna say descriptive statistics and inferential statistics? Those are very important from day one. We could talk about it because statistics has these two big branches. The first one, descriptives, involves organizing, summarizing, displaying data, right? This one right here is that involves, organizing, summarizing, and displaying data. So that's a real information. If we said in my class there are 24 students, I am out of 24 students, 12 of them, 12 of them identify themselves as female. Anyone can come and verify that descriptives, when you have your tables, your charts, your average, those are really um, descriptive. But for inferentials, it's like when you use descriptive or you use some samples, use involves using sample to draw conclusions about a population. Using sample data to draw conclusions about a population. Like when we do, of course, later, maybe the last three chapters would be on inferential statistics. For example, when we conduct a poll about elections, we call only 5,000 people over the phone and ask them who they would vote. So based on the outcome, we would conclude that based on the poll we conducted, we can conclude that this particular party, political party, would win the elections, or this particular candidate would win the elections. However, it's not because the survey, the polls say that the entire population would vote in that way, because it's only 5,000 out of 100 millions of people who can vote, right? So hopefully you enjoy this, and I'll see you in the next chapter, exploring data with tables and graphs. Take care.